And we are now going to start on Module 4. Module 4 has 4 different parts to it. What we'll be doing in Module 4 is learning how to solve a new equation. And we're going to use our skills from Module 3 about imaginary and complex numbers in this module. So if you please go to your notes. First, let's start off with the definition. We need to understand what makes an equation quadratic. We've already seen linear equations that have the value of the exponent being 1, and we've already seen rational equations that have fractions. So now we need to know what is the definition of a quadratic equation. It says a quadratic equation is in the form ax squared plus bx plus c equals 0. What that means is a quadratic equation is an equation. It's going to have an equal symbol. It's also going to have numbers and variables. But if you look closely at the exponent, it's no longer a 1. Now we have an exponent of 2. And that's what makes an equation quadratic. So it doesn't matter how many terms are in the equation. It doesn't matter what the equation equals. If your exponent in the equation is a 2, if that's the highest exponent, we call this equation quadratic. So if you look at my examples, x squared minus 4 equals 0. That's a quadratic equation. It has the x squared in it. The next one, 3x squared plus 2x equals 7. That's a quadratic equation. It has the x squared in it. 5 equals x squared. That is a quadratic equation. It has the x squared in it. But let's look at the last example, x plus 2 squared equals 0. Let's go to the board and talk about that one. So, if you have the equation x plus 2 squared equals 0, if you first look, the x has an invisible exponent of 1. So you're probably thinking this is linear. But remember, guys, you have to use all your knowledge of algebra. And we all know squaring means to write this twice. And we would be connected by multiplication. And we all know from algebra to multiply a binomial 2 terms times a binomial 2 terms, we have to use our foiling distributing method. And as soon as we do FOIL, F means first, x times x is x squared. There's the square. If we do our outers, x times 2 is positive 2x. If we do our inners, positive 2 times x is positive 2x. If we do our last, positive 2 times positive 2 is positive 4. And if we look now at our equation, we see the highest exponent is the x squared, and that's what makes it quadratic. Okay, let's go back to our notes. So now that we understand the definition of a quadratic equation, we want to learn how to solve it. The most important thing you have to understand is there's not one way to solve a quadratic equation. There are technically 4 methods. Now, it is important that we understand how to work all 4 methods because we're going to find out some of the methods don't always work, and we're going to have to make decisions. So with quadratic equations, not only do you have 4 different methods to learn, you have to learn when to use each method. Okay. We're going to start off today with the easiest method. Factoring is the easiest method to solve a quadratic equation. You all learned how to factor in basic algebra, and we want to use those skills that you learned. We don't want to waste them. So it's important that we follow the procedure here. In order to factor a quadratic equation, it says you must have your equation set equal to 0. That means all the terms have to be on the left side, and that the equal 0 is on the right side. So in order to factor, that's the first thing that's got to happen. Once you get your equation set equal to 0, then you're going to factor. And you learned 3 big rules of factoring in algebra. They were GCF, difference of perfect squares, and the trinomial rule. So we're going to review those 3 rules again today. Once you factor, your quadratic equation is no longer quadratic. It becomes linear. You're going to see that x squared disappear and become x to the first. But you're not going to have one x. You're going to have 2 x's. So the moral of the story is every quadratic equation is going to factor into two linear equations. And that will take us back to Algebra 1, and then we'll solve. And what we'll notice today that's important is we'll have two solutions. So let's walk through this procedure. I have 4 different examples I want to work with you. Okay, so let's start here. I have an equation. It has an equals sign. We've discussed this. All you do with equations is solve them. Solve means to isolate the variable and find out what number it represents. We have to look closely now because if we look at this equation, it has an x squared, which means it's quadratic. And we have to solve it by a different procedure. So just like a doctor does different procedures depending on what operation he's doing, you have different procedures to solve different equations. So to solve a quadratic equation, and we're going to use factoring today, the first step is get the equation set equal to 0. It's done. Step 2 is factor. And this is where you got to bring in all the stuff you previously learned. You have got to know the rules of factoring. So the 3 rules are GCF, difference of perfect squares, and trinomial. Let's look here. Do we have a GCF? Does x squared and 4 have something in common you could divide out? No. Is it a difference of perfect squares? Difference means you have a subtraction symbol. We got it. Perfect squares means something times itself. What term times itself is x squared? That's x. What term times itself is 4? That's 2. So we're going to factor this using our rule, difference of perfect squares, which I abbreviate DPS. So if you remember your algebra skills, you put 2 parentheses, and you say to yourself, what times itself is x squared? X times x. What times itself is 4? 2 times 2. To multiply to make a negative 4, one's got to be positive, one's got to be negative, and it doesn't matter which order you put those in. Make sure you bring down the equal 0 to keep it looking like an equation. What you have just done is you've done a magic trick. If you look closely now, there are no longer x squareds. This is x to the first, linear. This is x to the first, linear. But there's not one x, there are 2. So now you have 2 linear equations. And what you do is you set each of them equal to 0. So you take this first set, x plus 2, you set it equal to 0. You take the next set, x minus 2, you set it equal to 0. You're probably saying, why do I do that? Well, think about it from 3rd grade math. You have something times something equals 0. The only way 2 numbers can multiply to make 0 is one of them would have to be a 0. Okay, just think about your arithmetic skills. 2 times 0 is 0. 0 times 2 is 0. So we're saying one of these has to be a 0. So we're trying to find out what number we're going to put in this spot or substitute to make it equal 0. What number goes in this spot to make it equal 0? That's called your 0 property. So all you got to remember is when you factor a quadratic, you're going to have 2 x's. You're going to write 2 linear equations. And now you're back to Algebra 1, and you solve. X equals negative 2. X equals positive 2. And you could write that solution separate with a comma in between, or you could write it as plus or minus 2. Using the plus or minus symbol means there's both a positive 2 and a negative 2. We have 2 solutions. Just like with linear equations, you could check to see if you're correct. You could substitute these numbers in and see if they work. We're going to do a mental check today because this is a small equation. So if we take our negative 2 and put it in this spot, negative 2 squared would be negative 2 times negative 2, which is 4. 4 minus 4 equals 0. It checks. If we put 2 in this spot, 2 squared is 2 times 2, which is 4. 4 minus 4 is 0. It checks. Every time you solve a quadratic, you should get 2 solutions that check. If your numbers that you get do not check, it means you solved incorrectly. Okay, let's go to our second example. Here's our equation. There's the equal sign. X squared equals 5x. I see the square. I know it's a quadratic equation. It's not linear. So we have a different procedure. To solve a quadratic equation, step 1 is it's got to equal what, y'all? That's right, it's got to equal 0. So now we need to move a 5x over to the left. And from Algebra 1, we learned to move variables left and right, you either add or subtract. This is a positive 5x, it's being added. So I'm going to do the opposite operation and subtract it. From Algebra 2, can you subtract x squared and 5x? No, you cannot. They're not like terms. Remember, you can only add and subtract things that are alike. So because these are not alike, you write them in the correct descending order. And make sure you write your equals. These are going to cancel. They're additive inverses. There's your 0. So it's still an equation. It's still quadratic. But now that it's set equal to 0, you can factor it. Now we have to go through the steps. What's the first rule of factoring? GCF. Do these terms have something in common you can divide them by? Yes, they do. They both can be divided by the letter x. So we're going to take out an x, and we're going to tell me what's left. That's your GCF rule. What is x squared divided by x? That's x. What is negative 5x divided by x? That's negative 5. If you're having problems, that means you're going to have to go back and review your factoring rules. Because if you cannot review those rules, you're not going to know what to do. When you factor, you see an x and you see an x. You should always see two x's, but they're not quadratic anymore. They have exponents of 1. They're linear. So now we're going to write two linear equations. A lot of y'all get confused because over here it's very obvious. The two equations are going to be the two sets of parentheses equal to 0. And then you get here and you say, well, wait a minute, there's only one set of parentheses. Remember, guys, this is connected by multiplication. If you wanted to put a parentheses around this, you could. So our two equations are going to be the first x, and it's going to equal 0. And the second set of parentheses, x minus 5 equals 0. There's no solving here. This is an answer. The answer 0 is acceptable. It's on the number line. To solve for x here, we're going to isolate the variable, and we're going to get x equals 5. So this solution set is 0, 5. Okay? Everybody's with me? Let's get a little bit more difficult. So we reviewed factoring doing difference of perfect squares. We reviewed factoring doing the GCF rule. So what rule would be next? Okay, let's look at example 3. We have x plus 3 times x plus 8 equals x. Okay, this is tricky because I know what's going to happen. You guys are automatically want to make two equations because you see the two sets of parentheses. But you got to follow the procedure. And the procedure says the equation's got to be set equal to 0. Is that a 0? No, it's not. So you're going to think, well, just move the x over here. Can you take a term that's outside of parentheses and put it inside? No, you cannot. You all learned from Algebra 1 and what we reviewed in Module 1. To solve an equation, you have to have all the terms free. There cannot be parentheses. So we're going to have to use our skills of multiplying. And because we're multiplying a binomial times a binomial, we're going to distribute doing the FOIL method. So here we go again, what you have to know how to FOIL. First would be x times x, which is x squared. Outers would be x times positive 8, positive 8x. Inners would be positive 3 times x, positive 3x. Last would be positive 3 times positive 8, which is positive 24. Now, if you remember, when you do FOIL, you get 4 terms. If you notice now, there's your x squared. Now you have a quadratic equation which says, ooh, I want to let this equation equal 0. But you guys know when you do FOIL, you should take these two terms and put them together. So let's do our CLT, our collect like terms. 8x and 3x add to 11x. Now we can get our equation set equal to 0. We'll subtract x. And we're going to subtract x underneath the 11x because those are the like terms. You can't subtract x from 24, and you can't subtract x from x squared. So we bring down our x squared. 11x minus 1x is positive 10x. We bring down our positive 24, and we equal 0. It is very important you always leave the 0. If you forget the 0, then you no longer have an equation, and then your work doesn't make any sense. Now if you look, we're going to factor. So we did everything for step 1. We got our equation equal to 0. To factor, let's go through the rules. Is there a GCF? Can we divide these three terms by the same thing? No, we cannot. We cannot divide them by x. They all don't have an x. We can't divide them by the same number other than 1, and 1's not going to change it. So the GCF rule is out. Is it a difference of perfect squares? No way. A difference of perfect squares can only be two terms connected with subtraction. How many terms are here? Well, there's 3. We learned in algebra you call this a trinomial. To factor a trinomial, you think backwards of FOIL. See up here? We did FOIL and we ended up with 3 terms, 1, 2, 3, a trinomial. So now we're going to go backwards. So to factor trinomial, you always put 2 parentheses. You could think about this as doing backwards FOIL. Here's your first term. Here's your last term. So this is the outers and inners put together. Okay, what multiplies to x squared? X times x. What can multiply to 24? Well, there's lots of options. Okay, when I was teaching algebra, I told my students to write it down. It could be 1 times 24, 2 times 12, 3 times 8, 4 times 6. You can't go eeny, meeny, miny, mo and pick which option you like better. How you decide which option multiplies to 24 is you read the trinomial backwards. You want to add to what's in the middle here, 10x. So will 1 and 24 add to 10? No. Will 2 and 12 add to 10? No. Will 3 and 8 add to 10? No. Will 4 and 6 add to 10? Yes. And adding to a positive 10 means they both have to be the same sign. They both have to be positive. So now you went from having an x squared quadratic to having 2 x's. We're linear. So now we have our 2 linear equations. We set them equal to 0. And now we're back to algebra 1. To solve, we subtract 4. We get a negative 4 as a solution. To solve, we subtract 6. We get negative 6 as our solution. You don't get to choose which answer. They're both the solution. So you would say your solution set here is x equals negative 4, comma, negative 6. I could prove to you that that's correct. Let's take one by one and do a check. So let's take negative 4. If we put negative 4 in this spot, negative 4 plus 3 would be negative 1. If we put the negative 4 in this spot, negative 4 plus 8 would be 4 equals, and if we put the negative 4 in this spot, is that a true statement? Is negative 1 times 4 going to be negative 4? Yes, it is. Now we'll prove that negative 6 is the solution. If we put negative 6 in this spot, negative 6 plus 3 is negative 3. If we substitute negative 6 here, negative 6 plus 8 is 2. If we substitute negative 6 there, so does that make sense? Is negative 3 times 2 negative 6? Yes, it is. Every time you solve a quadratic, you're going to get 2 solutions. They both should check. Okay, I think we have one more example that's a little bit more complicated, so let's look at it. All right, let me erase this. It is very easy to make a careless mistake solving a quadratic. So you need to take your time and you need to show all your work. If you look, I never skip a step. That way I know I'm doing it correctly. All right, our last example. 6x parentheses x plus 4 equals x minus 15. So what we have learned from Algebra 1, Algebra 2, and now in college algebra is before we can do anything, we have to free our terms. You cannot have an equation that has parentheses in it. So we need to get rid of the parentheses by doing multiplication. Because we have a monomial times a binomial, this is just distributing. So 6x times x is 6x squared. 6x times 4 is 24x. Now if you look closely, my equation has an x squared, which means it's called a quadratic equation, and now I go through the process. To solve a quadratic equation, it has to equal what, y'all? 0. That's not 0. So we have 2 terms to move. To move an x, we'd have to subtract x. So now I have 6x squared plus 23x equals, these are going to cancel, additive inverses, negative 15. Okay, is it equal to 0 yet? Nope. So now we're going to do the opposite. We're going to add 15. You can't add a 15 to a 6x squared. You can't add 15 to 23x. So we're going to put that constant, that number by itself at the end. So we're in the correct descending order. Beautiful. So now we have our equation that's quadratic equal to 0. Now it's factoring time. So the first rule of factoring is GCF. GCF is, can you divide all the terms by the same thing? Well, they don't all have an x, so we can't do that. And 6, 23, and 15 cannot be divided by the same number because 23 is prime. So that's that. It can't be the rule difference of perfect squares because you can only have 2 terms connected by subtraction. How many terms do we have? 1, 2, 3. So this is the trinomial rule. Now here's the problem. This is not an easy trinomial. In Miss Black's world, I called this in my class the difficult trinomials. When a trinomial starts out with a number, a coefficient other than 1, it's a little bit more complicated. Remember, factoring a trinomial is always thinking about FOIL. FOIL, you have a first term, you have a last term, and then what's here in the middle is made by the outers and inners. I think of this as a jigsaw puzzle, like playing a game. To factor a trinomial, you have to get the pieces in the right spot. So I know to factor this, it's going to always be 2 parentheses. You always start with the first term. What can multiply to 6x squared? But now we have an option. 6x squared could be 6x times 1x. Or 6x squared could be 3x times 2x. I'm not a mind reader. I don't know which one's correct right now, so I'm going to write both down. After you do the first term, you go to the last term. The last term is a 15. Well, we have options. That could be 1 times 15, 3 times 5. You don't pick which numbers you prefer. You got to find the option that when you put those numbers in this spot, the outers and inners are going to add to 23. The outers and inners are going to add to 23. So this is like doing a puzzle. It's like playing a game. Some of you will get lucky, hit it the first time. Others of you will be like me and do it forever. So watch. If I put a 1 here and a 15 here, let's see if I'm right. Well, if I check my outers, 6 times 15 is 90x. 1 times x, the inners is 1x. Will 1x and 90x add to 23? No, it will not. So that means maybe I have the numbers in the wrong spot. Let's switch them and try again. So I do the outers. 6x times 1 is 6x. 15 times x is 15x. Will 15x and 6x add to what's in the middle, 23? No, it will not. So that means the 1 and 15 don't work here. So now let's try the 3 and 5. I'll put the 3 here and the 5 here. Let's check the outers. 6x times 5 is 30x. Inners, 3 times x is 3x. Does 3x and 30x add to 23? No, it does not. So let's switch them. We got one more opportunity here. Let's put the 5 and the 3. Okay, outers, 6x times 3 is 18x. Inners, 5 times x is 5x. Will 5x and 18x add to 23x? Yes, it will. We hit it, which means then we don't got to try this because this is not going to work at all. So factoring trinomials takes some time. They take some effort. You got to play the game. Now, because we said we want to add, the signs have to be the same. Adding to a positive, they would both be positive. You've done the magic trick. So the hard part of solving quadratics is the beginning. Getting the equation set equal to 0, step 1, and step 2, getting it factored. Once you get it factored, you'll always have 2 x's. You have 2 linear equations. You set them both equal to 0, and then you solve. And now we're back to algebra 1. We move the numbers to the right. We leave the variable on the left. We're going to divide by 6. 5 does not divide by 6 nicely. We prefer our answers in college algebra to be fractions. So this solution would be x equals -5, 6. The second solution is very nice. We would subtract 3, and we would get x equals -3. So when you solve a quadratic, how many solutions should you always get? That's right. You should always get 2. The answers could be both positive, they could be both negative, they could be one of each, they could be fractions, they could be decimals, they could be whole numbers. Okay, but just realize every time you solve a quadratic, you need 2 solutions. Okay, so we reviewed factoring. You need to go back and practice that. I'm going to get you on the next module where we'll see what happens if factoring doesn't work. Thank you.